Hello, good day. So, for this discussion, we will be talking about field soil compaction. Since we are already done with the discussion of the theoretical part of the soil compaction, no, the determination of the maximum dry density and the optimum moisture content, and the theories or mechanisms of our soil, no, and its characteristics during soil compaction in the laboratory. So this time, we will be talking about the actual conduct or actual adaptation of soil compaction in the field. So again, the source for this discussion is still the book by Braha M. Das, The Principles of Geotechnical Engineering, 7th edition. So now let us talk about the equipment or how do we conduct soil compaction on site. So how do we compact our soil on site? So we will be using compaction equipment. So these are the following, no, compaction equipment that we can use in order for us to compact our soil on site. So most of the compaction in the field is done with rollers. So the four common types of rollers are the smooth wheel rollers, the pneumatic rubber-tired rollers, the ship's foot rollers, and vibratory rollers. So we will be discussing each of these in the succeeding. All right. So first we'll have smooth wheel rollers. So this is how a smooth wheel rollers look like. So we can commonly see this in construction sites, just like the construction site for a road widening project or road concreting project. So smooth wheel rollers are suitable for proof rolling subgrades and for finishing operation of fields with sandy and clayey soil. So these rollers provide 100% coverage under the wheels. So with ground contact pressure as high as 310 to 380 kilonewton per square meter, they are not suitable for producing high unit weights of compaction when used on thicker layers. So that's why for example, our embankment, no, or our subgrades are designed to be of, for example, depth of more than 200 millimeters. So since if you are going to use this type of roller for your compaction of the soil, you would have to lay your soil on thinner layers, or for example in the DPWH specifications, you would have to lay your embankment or your layer in 150 millimeters to 200 millimeters thick only, so that you would be able to compact your soil properly. So dili siya pwede, no, nga baga diretso ang imuhang layer sa imuhang soil nga i-compact. So dapat siya layer by layer, no, nipis nipis nga layer by layer. So mo ni siya, no, ang actual picture, actual illustration of how these smooth rollers look like on the field. So next we have the pneumatic rubber tired rollers. So pneumatic rubber tired rollers are better in many respects than the smooth wheel rollers. So the former, no, are heavily loaded with several rows of tires. These tires are closely spaced 4 to 6 in a row. So the contact pressure under the tires can range from 600 to 700 kilonewton per square meter. So mas kusgan kay bali siya, no? And they produce about 70 to 80% coverage. Kay nganong 70 to 80 man, no, kaganiha ang smooth wheel roller kay 100% kay since straight man to niya, no, iyahang roller, iyahang drum straight man, whereas kani sa pneumatic rubber na yung mga spaces in between sa iyahang tires. That's why 70 na yung mga parts nga dili niya ma-cover. Pero mas kusgan siya, and then katong parts nga wala niya na-cover also ihapon tong balikan og agi. So compaction is achieved by a combination of pressure and kneading action. So muna siya, no, yung mechanism on how this type of roller actually compacts our soil. It is through pressure and kneading action. So muna siya, no? This is how the pneumatic rubber tired rollers look like on the field. So, unlike the smooth wheel, no, nga isa, gito siya kabuo nga drum diri, kani siya, na spaces in between sa iyahang mga tires. So the third one is the sheep's foot roller. So sheep's foot rollers are drums with a large number of projections. So the area of each projection may be or may range from ang sabot sa projections are this one, no, kaniyang mga giring-giring. Uh, they are of projection no, they are the area of these projections range from 25 to 85 centimeters squared. So these rollers are most effective in compacting clayey soil. So the contact pressure under the projections can range from 1,400 to 7,000. So grabe nagiging siya kakusgan, no? So that's why it is applicable for clayey soils. During the compaction in the field, the initial passes compact the lower portion of a lift. So compaction at the top and the middle of a lift is done at a later stage. So naa siya initial, no, initial og mga middle, yes, initial passes sa iyang mga lift. So napat siya iyang pamaagi on how this type of equipment compacts our soil, pero among the three so far, this is the strongest. So this is how a sheep's foot rollers look like on the field, no. So nagid siya dagko kaayo nga mga projection kining giring-giring niya, no. So we also have the vibratory rollers now. Vibratory rollers are extremely efficient in compacting. Akato sila mga roller raman to sila, no, pero naigay po uban nga while sila ga-roll o while ga-compact, no, mag-vibrate ang mga rollers. So muna ang mechanism, no, nay naka-attach nga mga vibrators sa atong mga roller nga kamulo siya tuyo, kamulo pud siya vibrate, kamulo pud siya og compact, nakatabang yapon to sa iyang pag-compact sa iyang soil. So vibratory rollers are extremely efficient in compacting rather granular soil. So vibrators can be attached to smooth wheel, pneumatic rubber tired, or sheep's foot rollers to provide vibratory effects on the soil. So mo ni siya, no, unsaon pag-attach sa vibrator sa atong rollers. So handheld vibrating plates can be used for effective compaction of granular soils over a limited area. So vibrating plates are also gang mounted on machines. So these plates can be used in less restricted areas. So muna siya, no, vibratory plates nga kanang, for example, there are areas that you need to compact and then dili kasulod ang katong mga rollers, no, road rollers, we call that road rollers man. Katong compaction equipment katong gi-discuss ganihan, no. So pwede ta mo gamit na mas gamay nga pwede ra siya i-operate with our hands, no. Yani siya kagamay. So dito na siya sa mga area nga dili kasulod ang mga road rollers rather. So now, let us talk about the factors affecting our field compaction. So, as previously discussed, no, on soil compaction, on the laboratory, such as the effect of soil type, no, we also have factors affecting our field compaction. So, in addition to soil type and moisture content, other factors must be considered to achieve the desired unit weight of compaction in the field. So, these factors include the thickness of lift, the intensity of pressure applied by the compacting equipment, and the area over which pressure is applied. So these factors are important because the pressure applied at the surface decreases with depth. So which results in a decrease in the degree of soil compaction. So during compaction, the dry unit weight of soil also is affected by the number of roller passes. So we have here on the figure, no, it shows the growth of shows the growth curves for a silty clay soil. So the dry unit weight increases, no, to a certain point with the number of roller passes. So beyond this point, it remains approximately constant. So in most cases, about 10 to 15 roller passes, somewhere diri no, nag-stop siya og increase and then somehow more constant din siya. So in most cases, about 10 to 15 roller passes yield the maximum dry unit weight economically attainable. Ang pasabot ani nga graph, no? So the more roller passes in our soil to be compacted, the more it increases its dry unit weight. Kaya in the soil compaction, no, in the field, atong goal gyud diha is to increase the unit weight of our soil wherein we provide a denser state for our soil. So figure in here also shows the variation in the unit weight of compaction with depth for a poorly graded dune sand where each compaction was achieved by vibratory drum roller. So vibration was produced by mounting an eccentric weight on a single rotating shaft within the drum cylinder. The weight of the roller used for this compaction was 55.6 kilonewton and the drum diameter was 1.19 meters. So the lifts were kept at 2.44 meters. So note that at any given depth, maninod, yes, the depth in meters and in feet. So the dry unit weight of our soil increases with the number of roller passes. So at duha lang no ka roller pass, diha lang iyang dry unit weight. And then kung lima nagkanam siya ka irog diri So padako man diri no man atong calibration sa atong dry unit weight diri. So from 15 padulong dito mag-increase siya. So that's why nagkadako atong number of roller passes no or nagkadaghan atong number of roller passes ni-increase po dayon ang atong dry unit weight. Okay, so another fact to note that from figure A here is the variation of the dry unit weight with depth for any given number of roller passes. So the dry unit weight, hence the relative density or D sub R, no, reach maximum values at a depth of about 0.5 meters and gradually decreases at lesser depths. So this decrease occurs because of the lack of confining pressure towards the surface. So once the relationship between the depth and the relative density for a given of soil with a given number of roller passes is determined, estimating the approximate thickness of each lift is easy. So, so now let us talk about the specification for field compaction. So in most specifications for earthwork, the contractor is instructed to achieve a compacted field dry unit weight of 90 to 95% of the maximum dry unit weight determined in the laboratory by either the standard or modified Proctor test. This is a specification for relative compaction which can be expressed as no, relative density or also referred to as in the field no is the degree of compaction. So it is the ratio between the maximum dry unit weight in actual over the maximum dry unit weight on the laboratory obtained in the laboratory. So times 100%, that is the degree of compaction because in the field no for item 104 or the embankment or we also have for the aggregate sub-base course na nasa lahi-lahi nga requirement for the degree of compaction. For example, for item 104 no, or the embankment, ingon si DPWH dapat daw 95% sa maximum dry unit weight dapat ang dry unit weight on the field. So for example, we have now from the compaction test that we have performed, it can either be the modified or the Proctor test. For example, we were able to get 2,000 kilogram per cubic meter of our maximum dry density or maximum dry unit weight. So ingon si DP or most contractor no are required to have 95% of that 2,000 kilogram maximum dry unit weight to be the dry unit weight of the compacted soil on site. So mo ni siya no. So kay since na-determine naman nato no ang atong maximum dry density sa lab. So when we perform determination of the dry unit weight on site, atong ginakuha na is the gamma dry on field. So ato na silang i-divide no ang duha times 100 muna siya atong degree of compaction, or also referred to as in most common geotechnical books no, it is sometimes called as relative density. So duha ra gyud na siya no, density from the lab and the density on site. So dito ni siya nimo makuha ang kaning dry density on site kung mahuman na kaog compact ang feeling nimo or na-attain na ang required number of roller passes no, nga may ka nga sige enough na ang compaction ato siyang testingan kung densest state na bagid niya o na-attain na bagid niya yung maximum dry unit weight. So mo nang mag-determine din kasi yan no. So we will be discussing further the methods that we can use to determine the dry unit weight on site. So for the compaction of granular soils, specifications sometimes are written in terms of the required relative density dr or the required relative compaction. So relative density should not be confused with relative compaction. So muna siya no, ang relative compaction muna yung formula. Pwede siya kanino, pero usually mo ginagamit nga formula for our relative compaction. So when you are asked for the relative compaction for the field compaction on site no, muna siya nga formula atong gamiton where here the dr here is the relative density and then the RO is the ratio of the gamma dry minimum and the gamma dry maximum. So the specification for field compaction based on relative compaction or on relative density is an end product specification. So the contractor is expected to achieve a minimum dry unit weight regardless of the field procedure adopted. So the most economical compaction condition can be explained in here na in the field or in this figure rather. So the compaction curves A, B, and C are the same soil with varying compactive effort. So let curve A represent the conditions of maximum compactive effort that can be obtained from the existing equipment. So let the contractor be required to achieve a minimum dry unit weight. So dapat na makakuha pa ng contractor o gamma dry maximum o gamma dry minimum kaysa pang formula no for relative compaction na may gamma dry minimum o gamma dry maximum. So to achieve this, the contractor must ensure that the moisture content falls between W1 and W2. So as can be seen here no from the compaction curve C, the required dry density or field dry density can be achieved at a lower compactive effort at a moisture content omega 3 no DW3 rather, sorry. So muna siya no the gamma dry minimum and then the gamma dry maximum. So nakandalay-lahay ni siya nga compactive effort where the same soil lang siya no. A is maximum ko na ang compactive effort meaning dako ang capacity siyang equipment no or daghan iyang number of roller passes. Kay syempre kung mas daghan ang roller passes, mas dako siya og construction cost kay syempre maggamit man ka og krudo ana no. So ang construction cost is magkan-anam gid siya kadako, that's why ma-consider siya nga compactive effort is high. So pwede pa din nato ma-attain ang atong gamma dry minimum with lesser compactive effort. So mo ni siya no kay ang mga value diri kani on the peak of our curves mo na siya ang gamma dry minimum, gamma dry maximum. So however no for most practical conditions, a compacted field unit weight yes, the gamma dry max cannot be achieved by minimum compactive effort. So hence, the equipment with slightly more than the minimum compactive effort should be used. So the compaction curve B represents these conditions, and you can see in the figure now that the most economical moisture content is between moisture content 3 and 4, and then wherein the W is actually the optimum moisture content for which is for the maximum compactive effort. So meaning ani dili kay nato attain ang atong maximum dry density kung low atong compactive effort or compaction effort, no. So and then diri dako ra pud kay ang requirement. So meaning ang most economical, no, or pwede gud siya nga ang atong moisture content is ma-fall siya between the range of our moisture content 3 or moisture content 4. So atong moisture content 4 diri is actually the optimum moisture content. So natay tay range nga pili ta mo go beyond our optimum moisture content, pero maka-attain gyapon ta og atong gamma dry max nga dili kay siya layo sa maximum dry unit weight, o dili pud kay siya gamay ra pud compare aning sa C. So now let us talk about the determination of field unit weight of compaction. So mo gini siya ang goal, no, when we do compaction, and how do we test if the compaction of our soil is already enough, no, compact na bagid kay siya, and then dili na bagid siya mo settle under the application of load. So we dapat identify gid nato na siya ang actual unit weight of our compacted soil. We have to compare that on our maximum dry density of the same soil, no, that we have obtained from the lab. So these, we will be talking about three method, pero only one of these is actually adapted on site. So when the compaction work is progressing in the field, so knowing whether the specified unit weight has been achieved is useful. So the standard procedures for determining the field unit weight of compaction includes, we have the sand cone method, the rubber balloon method, and the nuclear method. So we will be discussing them one by one. So first, we have the sand cone method, which has an ASTM designation of D1556. So again, this is the provision of ASTM, no, on how to perform the sand cone method. Step by step. So the sand cone device consists of a glass or plastic jar, muna siya na jar, with a metal cone kani attached to its top. The jar is filled with uniform dry Ottawa sand. The combined weight of the jar, the cone, and the sand filling the jar is determined W1. So batang lang nato, no. In the field, a small hole, muna siya na small hole, magbangag daw ta. Dito sa atong gi-compact nga yuta, magbangag ta dito. So a small hole is excavated in the area where the soil has been compacted. So if the weight of the moist soil excavated from the hole, W2, is determined, and the moisture content of the excavated soil is known, kasi syempre, from that, dito sa itong gikalutan, no, magkuha tag soil sample, ano na to siya tingbangon, mo to atong weight of wet soil, tapos ato siyang i-oven, no, and then ato pong timbangan after oven, na po rin tayo weight of dry soils, i-minus tong duha, that is, we can obtain our moisture content or actual moisture content. So diha pa lang daan, no, mabantayan na nimo kung ang actual moisture content ba sa imong compacted soil, duol ra ba siya or equal ba siya sa imong optimum moisture content. So, isa nimo na siya kabantayan, no. So kung duol siya or almost equal siya sa imong optimum moisture content, dako og chance nga na-attain sa imuhang soil iyang densest state or iyang maximum dry density. So, the dry unit weight of soil can be obtained mo na siya, no? W3, which is referred to as the dry unit weight of the soil in actual over is equal to, rather, the volume of the hole excavated. No, this is the weight of the soil from the hole excavated, no, over 1 plus the moisture content over 1. Pero actually, kani siya nga formula, we've already discussed this during the discussion of physical properties of soil, wherein ang formula dato sa gamma dry or W3 diri, no, gamma dry is equal to gamma wet or W2 dili lang siya. Actually gamma wet kina siya gamma wet over 1 plus moisture content. So kana siya nga formula. Di gina siya mag-change no. Gamma dry is equal to gamma wet over 1 plus moisture content over 100 gina siya always. Ang atong pag-determine sa actual dry unit weight or actual dry density of our compacted soil. So, muna siya no, ang mechanism sa atong sand cone method, meaning sa atong compacted layer of soil, magbangag ta didto no, muna siyang bangag. And then, timbangon nato, syempre magkalot man ta, natin makuha nga yuta diri. So, ato na siyang timbangon. And then, makuha na dayon nato ang iyahang weight ato kay timbangon nato siya no. Kay syempre, dili kita mawala sa concept nga unit weight is just equal to the weight over the volume. So, atong goal diri is sa sand cone method, dapat makuha nato ang weight sa soil and then ang volume sa soil or yes, the volume of the soil. So, first, we have to determine the weight of the soil. Sayo naman ako, kaya pagkalot diri, tigumon lang to nimo ang imong nakalot nga soil and then timbangon nimo. Muna to siya ang weight of wet soil. So, di pa to siya dry, no? Atong makuha na initially is ang gamma wet pa. Unya pa din nato ma-solve ang atong gamma dry using the formula katong kaganiha. So, dali ra man nato makuha no ang gamma ang weight of our soil. So karon ang unit weight man is weight over volume. So ang weight sayon na kay timbangon naman. And then ang volume ato siyang i-determine through the use of our calibrated sand or the sand with known unit weight. So kung ang unit weight sa isa ka substance, so for example our sand no, kung known ang unit weight sa atong sand, and then duha kibalang components diri no, ang unit weight sa soil ug ang unit weight sa sand. So we have the unit weight sa sand which is equal to the weight of the sand over the volume of the sand. So ang ganing volume of the sand to fill this hole is just equal to the volume of the soil excavated. So that's why we have to use a material or a substance with known unit weight kay para makuha lang nato ang weight sa sand diri, mag-compute na dahil nato ang iyahang volume. And the volume of the sand to fill this hole is just equal to the volume of the soil excavated from this hole. So after excavation of the hole, no, the cone with the sand-filled jar attached to it is inverted and placed over the hole. So the sand is allowed to flow out of the jar to fill the hole and the cones. After that, the combined weight of the jar and the cone and the remaining sand in the jar is determined weight 4. So atong weight 5 diri is equal to the weight of sand to fill the hole and the cone. So the volume of the excavated hole can be determined as the volume of the hole is equal to the weight 5 or the weight 5 which is equal to the W1 no minus this W1 is actually the sand the weight of the sand before pouring minus W4 which is equal to the weight of the sand after pouring. So makuha na to din no kay no man ang unit weight sa sand, makuha din nato ang volume sa atong hole. Alright, so at this time we have already obtained the volume of our hole or the volume of the soil. So kaganiha we were able to get the weight of our soil, and then we were also able to get the value of our hole, which is actually the volume of our soil. So from that, mga itong gamitin tayo is the dry weight of the soil excavated wherein na-minus na no ang moisture content sa atong actual soil. Na-minus na ang atong actual moisture content. So mabili na lang dayon ang dry weight of our soil. So, ito na siyang i-divide with the volume that we have obtained. And then, we will be able to come up with the value of our gamma dry. Kaya ang atong gamma dry is weight of solids na lang man. And then, the conventional or the more common no, nga formula for our gamma dry is the weight of solids over the volume of solid or the total volume. So that is how we conduct the sand cone method so that we are able to compute or determine the actual unit weight of our soil compacted on field. So another method which is not really common on site, no, is the rubber balloon method, or the ASTM designation D2167. So the procedure of the rubber balloon method is similar to that for the sand cone method. So similar lang daw sila, no, magbangag yapon ka. Pero this time we are not using a sand. So, a test hole is made. So, magbangag yapon ka, no, in your compacted layer. And the moist weight of soil removed from the hole and its moisture content are determined. So, parihayat man siya sa sand ko, no. Pagbangag nimo, timbangon nimo itong kinalot nga mga yuta, and then i-determine pa nimo yung moisture content. So, however, the volume of the hole is determined by introducing into it a rubber balloon filled with water from a calibrated vessel. So, muna siya, no, from which the volume can be read directly. The dry unit weight of the compacted soil can be determined by using a calibrated vessel that would be used with a rubber balloon also shown. Sama niyo, no? Ang nakalahian lang niya is how is the volume of the hole determined. Dito kaganihan, no, gi-identify nato ang volume of the hole using a calibrated sand of known unit weight para makompute to ang volume. Dire magamit siya og water and then a rubber balloon and a calibrated vessel which the volume of the hole can directly be read. So diri siya siya basa diri, no. So dali ra siya, hindi na siya mag-compute. Pero pareha ra gyapon siya og kalabasan, no. Ma-compute ra gyapon nimo ang volume of the hole. Pero ang pamaagi or the method used to determine the weight of the soil excavated from the test hole is just the same. So, timbangon lang ninyo siya, no? So, another method which is not really commonly used is the nuclear method. Kay destructive method, man gid siya, no? So, nuclear density or nuclear density meters are often used for determining the compacted dry unit weight of soil. So, the density meters operate either in drilled holes or from the ground surface. So, delete na siya. Magbangag, di butang siya. So the isotope gives off gamma rays that radiate back to the meter's detector. Dense soil absorbs more radiation than loose soil. So the instrument measures the weight of the wet soil per unit volume and the weight of water present in a unit volume of soil. So the dry unit weight of compacted soil can be determined by subtracting the weight of the water from the moist unit weight of soil. So magamit siya og gamma rays, no, to measure kung unsa ka compact ang soil. So dense soil ko, no, absorbs more radiation rather than loose soil. So through that it can determine the unit weight of our soil. So although this nuclear method is not commonly used, no, kay harmful siya or detrimental siya or na siya hazardous effects to human beings nga mag-perform sa test kay syempre you know gamma rays are not good for us humans. So that's why digin kini siya ginagamit ang nuclear method. So we have here, no, a sample problem on how we determine the maximum dry unit weight and the optimum moisture content from the lab, and then the actual unit weight on field, or the actual unit weight of soil compacted on field, and the relative compaction of our soil. So we have here the given, no, laboratory compaction test results for a clay silt are given in the table. So na ay corresponding moisture content and then corresponding dry unit weight. So meaning from this, kung makita na kitang moisture content o dry unit weight, automatically we can graph our compaction curve where we identify or we determine our maximum dry unit weight and our optimum moisture content. And then after obtaining the maximum dry unit weight and the optimum moisture content, you are now ready to perform the unit weight, field unit weight determination. Katong sand cone method, magigat mong gamitin diri kay mo siya pinaka-common, no? So, napad ito mga given diri for us to be able to determine the actual unit weight of our soil compact. Kasi syempre, katong dry density of the sand, dapat known siya, no? Then, katong sand and funnel, katong, di ba, namto siya funnel, and then ay siya padulong sa iyang um, jar. Although you can watch it on the educational video from YouTube that I have posted on site. So we also have the mass of jar plus cone plus sand before pouring, and then after pouring gitimbang na siya, no? And then the mass of moist soil from hole, kay bali nahuman na siya kandak diri, no? Nahuman na siya galot, and then the actual moisture content of our soil. So muni siya ang atong data or parameters that we need to know so that we can perform the unit weight determination on field. So first, we are asked to determine the dry unit weight of the compaction in field and the relative compaction in field. So first, we have here, no, um, we are asked to solve for the dry unit weight on field. So, muna siya, no, magamit dahil taog. First, we have the mass of sand to fill hole and the cone, which is mass of sand, no, kay first we have to determine kay given naman, no, ang atong weight of moist soil nga atong gikalot from the hole or the test hole. Atong nalang goal is to determine the volume of the hole, since naa may given diri nga value of actually this is the weight of the sand plus the cone plus the jar before pouring and after pouring. So mo ni siya, no, 2.81 kilograms of sand daw, or i-minus pa ditong sand in funnel kay maapil man po to siya kayabo. So meaning, for you to be able to determine the mass of sand used to fill hole is you have to subtract from the mass of the sand plus jar plus cone before pouring minus pouring and minus the sand in the funnel. Kung ito siya ilabot. So you will be able to arrive with the value of your mass of the sand used to fill your test hole katong gibangag nimo, no. So and then the volume of the hole is just equal to the mass over the dry density of the sand, kay no naman ni siya given man siya, no. So from that, you're able to solve for the volume of the hole, which is equal to 0.00144426 cubic meter, and this is also the volume of the moist soil that you were able to excavate from the hole, kay same raman to siya nga bangag, no. Although lahi nga material, we have the sand and the soil, same ra gid tong volume sa atong gikalutan, di gito siya mausab. So from that, since known man atong mass of moist soil, no, and then we were able to compute for the volume of that hole, so we are able to solve for our gamma wet, which is equal to 2.084 kilograms per cubic meter. Then naman tay actually dili man gid gamma wet ang ginapangita sa atong unit weight determination, no. That is actually the dry unit weight. So from this gamma wet value, we just have to simply use the equation, no? A gamma dry is equal to gamma wet over 1 plus moisture content over 100. And then automatically, we are able to solve for our actual dry unit weight on field. So mo na siya, no? Ang ato kuno after the compaction, ang implication ani is that after kuno compaction of the layer of soil on site. So for example, prior to pouring, no? Prior to concrete pouring, gi-prepare na ang sub-base, mana siya compact, mo na daw ni dayon siya ang density or ang unit weight sa soil nga gi-compact nato on site, which is equal to 18.56 kilonewton per cubic meter. And now, we have to determine kung enough na ba ni siya or nakapasar na ba ni siya or equal ba siya or how close is this value to our maximum dry unit weight. Kay actual man ni siya, no? So, since we are not given directly the value of our maximum dry unit weight and our optimum moisture content, we are only given the values for from our Proctor test, no, from compaction test. Then from that, we are able to graph those value tong given sa table kaganiha, and then determine our optimum moisture content, wherein the peak value for our dry unit weight is obtained, which corresponds to our maximum dry unit weight. So as you can see, na if you want to go back on the lecture notes, makita nimo dito nga ang maximum value is actually 18.9, and diri nganong 19. Pero actually, that's why nga not from that table we are going to determine our maximum dry unit weight. Kailangan nato siya i-graph. Kay for example, in ani nga case no, ang mga value is katag. And then the peak value is actually not on the dots which correspond to each of those value. Nasa diri somewhere ang peak value, no? So meaning, na ang maximum dry unit weight. Kani siya nga value diri, dili kaning point diri dili pud kana jud siya danang peak value regardless kung given ba ang iyahang value directly from the table kay dili man ni matagan ang compaction curve behavior sa atong soil. So in order for you to determine this peak value, you just have to project that on your y-axis. Bana-banaon lang din mo siya kung dagko kay ang calibration. So nasa sa itong ano, so more or less nasa sa 19 kilonewton per cubic meter. And the moisture content that corresponds to that peak value is what we call the moisture content. So from this, our maximum dry unit weight of the soil is actually equal to 19 kilonewton per cubic meter. So for us to solve our relative compaction or the degree of compaction of our soil, i-divide lang nato ang gamma from the field or gamma actual over the MDD or maximum dry unit weight. So to determine the degree of compaction, it is gamma actual over gamma from the lab, which is the maximum dry unit weight. So divide mo na silang duha times 100, and then we will be able to obtain our degree of compaction, which is equal to 97.7%. So meaning, na-attain daw nato ang 97.7% sa maximum dry unit weight sa atong soil. So how do we know nga okay na kaya na siya mga 97 nya dili siya 100, no? So naman siya mga provisions or mga tolerance. So for example, ang contractor is only asked to have a 95% degree compaction, no, which corresponds to the 95% of the maximum dry unit weight daw dapat imong ma-obtain in your actual dry unit weight. So kaning 97.7% kung pangutaan ka rin sa contractor nga, ma'am, pwede na ba buhusan? Pasar na ba? Yes, pasar na. So, 95 naman ang requirement. So, 97.7 man itong na-obtain, meaning ni pasar siya. So, meaning, you are able to attain the densest state of your soil, and you can now be assured that during the application of load, your layer or your soil layer will not or will only have minimal settlement. No? And from that, you can be assured of the fact that your structure can support the loads that it is designed for, or you can prevent failure from your foundation of the structure. May it be a pavement, no, most commonly. So ma-assure ka of the quality of your structure. So that would be all for the field compaction part. Thank you so much.